Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're back in here on our number 40 taper holders for the K&T. We've cleaned up the lathe here. We've gotten about a half a trash can there out of chips there, and got everything all kind of cleaned up. We're going to be changing out our tooling here. We're going to come in here and we're going to take some finer cuts to bring the size down close. We're not going to take it to finish size, but we want it to be down close enough to where we could start fitting it in, checking the fit into the spindle itself on the K&T. And we're going to be taking the diameter down here rough to our diameter we want on each of the holders. We're going to make a 2-inch holder, and then we're going to make another 1.25-inch holder. I thought I wanted an 1.5-inch holder, but I started investigating on what I actually have for end mills to be able to put in on this thing, and I don't have any 1.5 inch. I have a ton of 1.25 inch, and then I have that one obese 2-inch that we want to put into the holder, and that's what this whole thing is all about. So anyhow, let's bring you in and let's start whittling down on the OD here. Okay, I know this diameter here is extremely big for what it actually needs to be. I took my snap gauges and reached in the spindle nose of the K&T, and I got right around 1 inch 25 thousandths. Now this right here is 1 inch 78 thousandths. So I can bring this down to at least that diameter, but this on the drawing actually calls out to be about 9. Don't tell your wife you got a new little black book. Alright, so I checked this diameter here, and we said 1 inch 78 or so. In the engineer's black book here, D2 here for 40 is 0.996, and in the machinist's handbook it was 0.998 in that realm. So they're within a couple thousandths of each other. So I can really, in reality, between that actual number there, and we know what our bore is on our K&T, so we can definitely bring this into a fitting diameter and still be way above our finished diameter if we're going to make it right to the book. There we go. All right, we're just going to touch off here, and we're going to take 10,000 just to see what kind of a finish we got with this insert. This is a D&MP with the positive action on the chip brake there. Yeah, it's still kind of a terry finish. It's 4140, you know, it's not the funnest stuff to try to get a finish on, unless you're really whipping it up on some speed there, and my lathe's not great on the top end there as far as listening to it whine. Alright, we got 1 inch 50, 3. I'm going to try a 5 thousandths cut, and I'm going to reduce the feed rate a little bit. We got a pretty decent finish there now. We're going to try to bring it down to about like 1 inch 20 thousandths, okay, and we're 1 inch 43 right now. So it's taking what we want, and we're bettering the finish right now. Okay, I'm getting ready to pull out this insert here. We were pretty well pleased with this SECO insert here. I think it was a TP 200 grade on there, and pretty large radius there. I think it's a 16th radius or so pretty good radius on there. And that thing was still going. I'm not pulling it out because it wasn't working. I'm pulling it out because we want to change up. And I don't have any of my regular Sandvik D&M's P's that I normally use, but this is Kennametal. This is grade KC 850. And let me blow that pocket out before I put my insert in there. All right, we'll get that. Lightly. So many people I see get down on the big handles. Just lightly snug your inserts in there. You don't need to crank them on in there. I've seen things get hot and then contract there, and then you almost have to drill out those Allens because somebody's way over tightening them. Okay, we fired up the tracer. I'm going to go ahead and put this in reverse and reverse the feed. Alright, now I'm going to back this off just a couple turns. This should still come in, and our pattern and everything else is still in the same position, so we just kind of creep this in here and we touch, we come back, we eyeball. That's the first thing we do, is eyeball a step and look at the bit, making sure that it's pretty well there. We come on up here and it should just get to that surface, and then it's following it out. Excellent. Okay, now we can fire off the machine and come into it. And of course, when we come back over here and we come in, it's going to be off of this surface right here. It's not going to touch this, and it's going to come in here, and then we'll probably be touching in that root. But this root right here, we're going to come in here, we'll dress that off, single point, and that'll be its own thing. But this angle from here to here and that diameter right there, we want to bring that down to where it's just about as close as this is to finish size. Okay, first thing we're going to do is we're going to fire this off, and we're just going to be rolling it back and forth in this area right here until we make a light cut. Okay, there we go. All right, we're going to let it cut from there out. Okay, that's okay that it didn't come in here and quite kiss that. That's all right. All right, so now we're going to measure this diameter right here, and this mean diameter right here is supposed to be close to 1 3/4. And we'll go ahead and roll this back to our 0 point here. Okay. 1/786 right here now. So we could take another 10 or so off of here, and we'll still be in that realm of being slightly oversized in here. Of course, this is going to get heat treated, and then we're going to grind this finish in here. Okay, we're going to go ahead and crank in 10 thousandths for a cut here. And we're looking at it, and you can still see that we are just off of that surface right there. All right. Now, as we come on down here, and I'm going to go ahead and fire it off before we drop to the end. On the roughing of this diameters here, you saw with a light cut, it plunged in and it raced in, because that 30 degrees to this angle here is the travel of the hydraulics. So as you're coming off of that strip that I clamped on the back there, you're falling off a square edge, so that's leaving that stylus on its own path to come in, and the hydraulics are just going to push it. So that's why you saw on a light cut it plunged in there really quickly, and on a heavy cut it actually had enough tool pressure in there to make it happen smoothly. That's the difference. That's what we were seeing in the last video. All right, I'm gonna roll this off until it goes in there real slow by hand, so that you will see. Actually, I'm feeding it half the speed rate, so let's see how that actually looks, and maybe you'll see that in slower motion. And the hydraulics will still come in and rush in, but it's not meaning that it's speeding anymore, and it's not going to be taking any more than I asked it to take. So it's not plunging in and causing more material being taken off of here. It's just freely coming in and plunging until it gets to that depth by the hydraulic tracer. Here we go. Hello, turn right. $770, $761. All right, I think I'm gonna leave it right there right now. I've polished this up a little bit. All right, let's go ahead and turn off our tracer, move it back out of the way. And we're gonna set up one more insert here. I want to set up one that we don't use too often on the video because we just recently have acquired it, and we're going to hog some of this diameter off with it. Okay, in one of the last care packages that Dennis Nolan sent us from SECO in Niagara was some inserts. These are inserts WNMPs 432 MF-1. All right. This package right here is for use with titanium or bronze. We're not doing that today. This one here is for use with all types of stainless. We're not doing stainless today. And this one says carbon, alloy, and tool steels. We're going to go ahead and we're going to pop in one of these, and we're going to see how that does across this surface here. Okay, this has got its own little wrench for this. Okay, so we lift that up and we get that out of there. Now I really don't know what grade this was. I have the box somewhere, but I don't remember what grade this one here was. So we're going to set that off to the side, and we're going to put this one in here because we want to know the grade for the alloy that we're trying to cut and what performance we're getting out of it. Should have just left that in there. I'm sure I got it well enough, tight enough. Don't want to over tighten inserts, like I said before. All right, we're going to come over here and we're going to set our angle approach to this, and so that our travel can come out of here. This is near 4" now. We want to bring it down real near 3.5. So we're going to just take 3.5 all the way down as close as we can. When we flip this around, we're going to make the other side 3". And we'll bring that 3" back to about wherever it is here, and then we'll be parting off this, and we'll have two different holders. But we're going to go for that first. Before we part it off, we are going to go ahead and go for our hole and our threads on each end, but that's in the next step. We're all set up here, and I have maybe just a couple degrees off of 90 here, giving it a little bit of a lead angle. All right, and we're going to touch off. Now we're at like 3 inches, 990, something like that. So we have basically about a 1/2 inch to come off of this thing. And so I'm just going to, let's not mess around. Let's go ahead and jack in 1/8 inch to start off with, and let's see what we got. All right, we're going to call that 0. We're going to call that 1/8 inch. And we're going to call this feeding it. Okay, I gotta go change my flip-flops. Okay, that was 692. All right, so we safely can go another 150 and still be above our diameter there. So we'll jack in another 75 thousandths per side. Here we go. Okay, I just put my CNMP in here, and we're just going to go ahead and we're just going to break this edge down here and this edge up here. Just by hand and by eyeball. we were coming in real close on, you know, we moved our carriage over here, so we were coming in real close with our stylus down here on our part here. So that's why we had to take a little bit of time. We caught it out of the corner of our eye, but all right. So just broke that, and now we're set up. Let's put a steady rest here and come in and drill and tap our draw bolt hole. All right, we just slid our tailstock in here after cleaning up the rest of this. We put in the steady rest, we slid it in, we locked it down in here. I'm still loose on the 3 rollers here, and we're just going to bring in, we like them just to know that we just, all we got to do is, and we're there. And we're going to go ahead and spin this up, and then we're going to get the feel of our rollers against the material. And this is how we set our steady rest. All right, now we'll go ahead and we'll set up our drill. I believe we're going to put 5/8 11 in here. Let me see what my little black book says. And oh wow, look at that, personal ID right on that page. Okay, and 5/8 national course. So that's 5/8 11. Alright, if we were doing it metric, it'd be the M16 thread. Alright, I just looked in the little black book there, and also the machinist handbook. And machinist handbook says that this thread here and hole is usually about 1 and 15/16 or so for American standard, and it's like 2 and something for British standards. But almost every one of my holders goes all the way through, which isn't a bad thing if you want to reach in there and push out a stubborn end mill that might have been in there and the coolant got a little rusty or whatever, and you want to push it out. You can always do that. What am I going to actually do here? Well, I think we might put a through hole all the way through, but I might only carry the 5/8 down a certain depth there. So we're going to go with a pilot hole, and we're going to get down in here to where we can make that decision. Okay, we ran the pilot down. We ran our 17/32, and that's the tap size for 5/8. We ran it down till we buried out the flutes in here, so we're about in this area here. We'll take it in a little deeper, but it's deep enough now for our threads. The next thing is there is a little bit of a relief that is the diameter of the threads, which what it calls out is 200 thousandths deep there, and let's see what it actually measures in here, and it's like 670. So we're going in with our 5/8 drill. If it drills just a little bit over, we're not concerned about it. We're only going to go in about 3/16 of an inch there, and after we go in there and we tap that out, we're going to set our compound up, and we're going to be putting our 60-degree center in here, so we'll be able to run our center in again for any purpose later on, or setting it up for anything else on a mandrel, or doing anything that we need to reset this up to grind it and finish it. So we want to have a true center support with our arbor. So that's what we'll face our own center hole in the end of it. We set our tailstock at 2 on the money there, so we can just bring that line out until we got our 3/16 of an inch, and that looks like it right there. That looks good. Okay, here we go. We got our tap. This is a pretty big tap to be doing this, but we're gonna give it a shot anyway. It's not the sharpest tap in the house. All right, and we're just gonna lube it up, lube the hole, stick it in it. All right. And here we go, on the way out. Okay, I have a slight trace of the AOD tap against the major diameter there, and I'm going to go ahead and come in with a boring bar and take a skim just down to the threads there, and then I'm going to feed the 30-degree angle, and then I'll come out here and I'm going to give the 30-degree here so that we have the included 60 for the live center. Here we go. I'm just taking a couple at a time here to see if we can get it cleaned up. That looks like it cleaned it. I like that. Okay, right there, 0. I'm just going to take another thou, and I'm going to come in just the 3/16 of an inch. Just feeding it by hand. There's 100. There's like 75 right there. Okay. Alright, let's feed this angle out here. I don't want to do that inside thread angle with the 30 this way. I want to do it 30 the other way. So I'm coming off the same angle as the thread. Sometimes they just radius this, but I'm going to put the 60-degree angle in here, or 30 per side is what I'm doing. And I like it to be about 100 thousandths on the landing there. I like that. All right, let's see if I can get my short drawbar in here. Let's see what we got. Nice. Okay, I think I'm going to take one dress smooth cut off of here, and we'll be ready to flip this thing around. Alright, with the DNMP, we should be able to reach in there and grab that. And let's see here. We'll go ahead and we're going to face in a little bit. Alright, there we go. And I'm just going to touch. Come back out. I'm going to give it about 3 thousandths or so. There we go. And I'm just going to fade it out by hand here. Okay. All right, a little polishing by hand will be great. let's flip it around. Until the next episode, get her done.